Hello subscribers and non-subscribers alike. So this is the 3-unit version of exponential change, and this will be a nice short one. Oh god. Should have written the heading before, like I normally do. So, the 2-unit version of exponential change is just the derivative of some quantity, we can use n, p, whatever, is a constant times the quantity. And the constant is the proportionality constant, right? And we're only concerned in terms of this with direct proportion, right? If it's inversely proportional, we need to do other things that are beyond 2-unit and not beyond 3-unit, but we can talk about that another day. And so for this, we get the pocket result, right? Which says that, well, pocket is if I use n, but p, sorry, so it's n naught e to the kt, right? So if it's a positive constant, that means that they both go up together, so that's growth. And if it's a negative constant, it means one goes up, one goes down, and that's decay, right? Maybe I should write that down. So k positive, growth, k negative, decay. And we're doing the same thing for 3-unit, except we're saying, and maybe I'll switch to p, let's live a little. So let's say that to p to t, come on, there you go, is again a constant times the current population, but it's actually not the current population, it's the current population minus something else. Let's use q for quantity. So that's fixed. And if you remember, they're both fixed, right? They're both constants. If you remember last week we talked about, it's 3:15 by the way, in case you can't tell. So we talked about a body being left outside and coming out of a freezer, presumably, I think the problem was, and coming up to room temperature, right? So in that sense you say that the change in the temperature, which would be P, with respect to time, is some constant times the current temperature less the air temperature, which makes sense, right? And again, the size of k and all that stuff is going to be important. It turns out that in this scenario, we can then write that p equals the quantity plus a constant times e to the kt. Right? These formulae are the same. And again, to do this, I would differentiate. So I'd go p dash equals ka e to the kt, chain rule, which equals k times p from over here minus q. Exactly what I needed. Right? Those are the questions, and the working is going to be virtually identical, except the only difference is going to be there's now 2 unknowns, so I'm going to need more variables, more data, right? 1, 2, 3 things. Oh, sorry, I should have highlighted K there. 1, 2, 3 things. I'll need 3 pieces of data instead of the normal 2. Alright. So detention tomorrow for anyone who doesn't tell me what this photo is. I think it's like a Doctor Who thing or something. I don't really know, but whatever it is, all I know is I can't stop looking.